So free response question number 1, we have a manager of a company who's interested in comparing the gas mileages for cars manufactured in country A and cars manufactured in country B. So he selects a random sample of 100 cars from country A and another random sample of 100 cars from country B. And so they gave us the box plots for each country, and they asked us in part A to compare the distributions. When they ask us to compare distributions, we must compare 4 things. We must compare the shape, the center, the spread, and if there are any gaps and outliers, we must mention them. Plus, all our answers must be in context of the question. Okay, so the context is extremely important. We start by, let's just go in general, talk in general about each of those. So for when we're comparing the shape of 2 distributions, usually we talk about the skewness. And so what do I mean by skewness? So a distribution can either be symmetric, or it can be skewed to the left, so the tail is pulled towards the left, or it can be skewed to the right skewed, so the tail being pulled towards the right. And in a histogram, for example, we can have a unimodal distribution with 1 mode, bimodal, 2 modes, or for example, a uniform distribution where all the bars in a histogram are the same height. For the measures of center, usually for the measures of center, we calculate the mean or the median or the median. Now, in a box plot, we can only compare the numerical values of the median, because in a box plot, we're only able to see the median and not the mean when we're talking about measures of center. So the numerical value of the mean, we're not able to calculate it from a box plot. However, if we were given a histogram, we are able to calculate the mean. Okay, for the median, you're able to get the median for both box plots and histograms. Okay, for the measures of spread and variation, we have the interquartile range, the range, and the standard deviation that we can compare. Now, in a box plot, of course, we can compare interquartile range and range, whereas we cannot calculate standard deviation unless it's given. Okay, the numerical value of the standard deviation. And so what do we have here? We can also, so we note that the median is the strongest measure of center. What do I mean by strongest measure of center? I mean it is the most resistant to changes in our distribution or to gaps and outliers. So the median is the strongest measure of center. It's least affected by gaps and outliers, and it's most resistant to them. Whereas the mean is a weak measure of center. It is highly affected by any changes in the distribution, and it's usually pulled towards the tail. Okay, so if a distribution is skewed to the left, the mean is pulled towards the left. And if a distribution is skewed to the right, the mean is pulled towards the right. Okay, and the interquartile range for the measures of spread, the interquartile range is the strongest measure of spread, strongest measure of variation. So it's least affected by changes, gaps, outliers. Okay, whereas the range is the weakest measure of spread. It is the most affected by changes in our distribution, changes such as outliers, gaps, etc. Okay, how do I calculate the interquartile range? Is Q3 minus Q1. Okay, IQR represents the middle 50% of my data set, and the range is just maximum minus minimum. Okay, and standard deviation, we can get it from our graphing calculator. Okay, so for now, let's talk about gaps and outliers. For gaps, usually if we're given a histogram, it's easy to identify a gap. In a distribution, we can easily identify a gap, whereas in a box plot, it's easy to identify outliers. Okay, either by calculation or they draw them for you as stars or dots outside the box plot. So, of course, all these must be compared in context of the question. So now that